Look at our first question as we go through our quiz. Grades were all over the place. Every possible grade was received on the course of the quiz today. So let's make sure that we understand where we might have made mistakes. Which equation has the same solution as 2x squared plus x minus 3 equals 0? Let me just mention a couple of things about your test coming up Friday. There will be no sequences on your test. That's what we're doing now. There will be lots and lots of quadratics, factorings, graphings, etc. It is critical. We have spent a lot of time on it. I could have done that. I could have given you the test on Wednesday, but I don't like giving tests in the middle of the week. I like to give you the homework on the weekend. So we covered 2 days because I didn't want to waste 2 days, and then we'll have the test Friday. But the sequence of stuff will be on the test after this. So you'll have lots of questions like number 1. 2x squared plus x minus 3 equals 0. And what they're really saying is, if you just take a look at the choices, you got to factor this. But this 2 in the front is bothersome. So then what we have to do is we have to say, okay, I got this 2 in the front here. I can't get a common factor, so I go to plan B. And I multiply that 2. I get x squared plus x minus 6. I factor, and then if I multiply by 2 here, what do I have to do to balance it out? Divide by 2, which I do. And elementary school trick, 2x plus 3. And over here, reduce x minus 1. That would be choice 4. Okay? Questions? Preguntas? All right, now we go to the next one, which is your vertical horizontal shift question that we have been pounding, I'd say last week, and a little bit yesterday we mentioned it as well. The purpose of this 3 is to either make it more narrow or more wide. I love Juliana's mom is a math teacher. She says that she used the word stretch. I love the word stretch. Unfortunately, I've never seen the word stretch used by the state. They should use the word. They like to use narrow and wide. So we go with narrow because that's what it makes it in effect. This says minus 2. Remember, it's always reversed in the parentheses. So that's 2 to the right. And this is vertical shift up 1. So over here I reminded you that this is horizontal shift. That's why we use an H. And we use K for vertical, spell it with a K. All right? So this means it's going to go up 1, it's going to go 2 to the right, and it's going to be more narrow. That is choice 2. And now we get to number 3. Number 3 is a really interesting question because we really haven't done everything necessary to understand this mathematically. Let me rephrase that. We did do everything necessary a long, long time ago in a place far, far away. However, I'm sure you forgot. So then the question is, how do we possibly come up with an answer given that most of you, the overwhelming majority, forgot? Kim, you with me here?
Yeah.
You sure? Because you're not even facing forward. Let's turn these on the desk. Right? There we go. Okay. You just try all the choices. You plug in choices 1, 2, 3, and 4. Make sure it works for all of the numbers in the table, all of the possible pairs, 0, 25, bless you, 2, 15, 6, 25, bless you, and so on. So you can just try all the choices. But there is another way, and that way is pretty cool. Look at the 4 choices. Some of those choices are linear, like y equals mx plus b, and some of them are exponential. Look at how the numbers are changing in the table. What do you think it is? Yeah, it's definitely going to be exponential. So get rid of choices 3 and 4. You only need to try choices 1 and 2. You substitute those in, and you get your answer. The other possibility is that you could use an exponential regression to do it on your calculator. Rather not get into that now. We talked about that a while ago, and we will talk more about it at another point in time. Okay, any questions on your quiz? Yes?
For that one, what numbers we plug in for like the T?
You plug in 0, and then do 25 to the 0. What's 25 to the 0?
0.
No, what's anything to the 0, guys? 1, good. Obviously that doesn't work. Now let's plug in this one. Plug in a 0. What's 0 plus 1? 1. What's 25 to the 1? 25. Let's try a 2. What's 2 plus 1? 3. If you do on your calculator 25 to the third, you'll find that answer. And you do that for each of them. Okay, great question. I'm sorry for fluffing over that. All right. Now, today's do it. Oh, we got to go over the homework first. Sorry about that. All right, let's take a look at last night's homework answers. What you're looking at right here in front of you, this is what your test is going to be a lot like. Now, we have done how many homeworks with these kind of questions on it? Lots. Mega amounts. Copious amounts.
Huge amount.
To use a little fancy vocab there. So, you should be able to do these. If you have problems, library tonight, 5:30 to 7:30. Tomorrow, Thursday, extra help here. Get it down pat. Yes.
Is simplifying radicals gonna be on the test too?
There's not like a section that says simplifying radicals, but you would be expected to simplify the quadratic equation all the way through.
Okay.
Now, let's say that you get that question and it's worth 3 points. You would get 2 for doing everything right except simplifying the radical.
Okay.
You would lose 1 point to simplify the radical.
Because I know how to do it up to the point where like
Right.
before simplifying, but I don't know how to do
I agree. You have 3 days to learn how to get that last point. And I'm confident you can. We're going to do a little bit more of that in a couple of minutes. Okay, any other questions? All right, bless you. Let's go to the next page on the homework. Hence the term squared. We're kind of making squares out of these figures when you multiply it by itself. So it's kind of like area, length times width. When the length and the width are the same, it makes a square. Oh, I wrote this wrong. This is my daily dumb mistake. I do it every day. It should be 50 squared, not n to the 50th. I'm an idiot. 2,500. My daily dumb mistake. I feel like you play Lotto and not Lotto, Jeopardy, and they have double Jeopardy and the bells ring and everything else. This is like the moment when the bells should ring in class. All right, there's my graph. What shape does that make?
A line.
No. What is this here? What kind of function?
Exponential.
No.
Oh, it's squared.
Squared. Squared is called what? Parabola. It's quadratic. It makes a parabola. There's my parabola, or half of my parabola. The other half would be over here. It does look like it's exponential, but there's 2 big differences. First, we didn't plot any negatives. If we would have plotted the negatives, they would have went up. Second, it actually touches the axis. In an exponential, it does not touch the axis. It comes really, really, really close, but it never touches. Remember the word asymptote from way back when. All right, now, here's some simplifying radicals. And this is like, you do not need this to pass your Regents exam, and it does drive kids crazy, but this is the kind of thing that the kid who gets the 90 can do. All right? There is each of the simplifications for you. Any questions about A through D? Which one are we looking at? That's a 3. Should be 10 radical 3. Yes.
For D, you got a different answer.
I'm sorry, for which one?
D, I got negative 3, and then the cube root of 2.
Oh, my second daily dumb mistake. Very good. It should be negative 3 cube root of 2. For some idiotic reason, I thought 8 times 2 was 54. Very good. Any other questions? All right, let's go to I want to call your attention to letter G. First off, E is like a bonus. I don't know if you realize the square root of x squared is just x. You do it all the time with Pythagorean theorem. Okay, I don't know if you ever thought about it. That's 4x. Letter F, you just multiply the -5 times -2. That gives you 10. And then 8 times 6 is 48. All right, and then if I left an answer like F, would I be correct? If I left the answer like F, would I be correct? No. Why not? F can be simplified. We're not done. See how it says the square root of 48 right there? Is there a biggest perfect square that divides into 48? 16, very good. So, I'm going to do 10 square root of 16, square root of 3. What is the square root of 16?
4.
4. What's 10 times 4?
40.
40, so I get 40 radical 3. Now, I went over to, oh, that was H I did there. Here's 5 radical 8. God bless. Is that finished? Is that as far as it can go, or can I go further? What you really want to ask is, can you simplify square root of 8? Yes, what's the biggest perfect square that divides into the square root of 8?
4.
4, good. So I get 5, square root of 4, square root of 2. This becomes 2, and 5 times 2 is 10. So I get 10 radical 2. So let's go back, and I'm going to explain something about F and G by looking at H. Division is the same. -24 divided by -12 is 2. 120 divided by 6 is 20. So now, if I break this down further, it's square root of 4, which is 2, square root of 5. 2 times 2 is 4, so I get 4 radical 5. Now, I want to compare that in theory to 2 times 2x. Everybody, what is 2 times 2x? 4x. It should be pretty simple at this point. But doesn't x stand for anything? Right? As a variable, doesn't it stand for anything? So 2 times anything is just 4 times anything. Can't anything be a radical? So 2 times 2 of those radicals should be what? 4 of those radicals. So there's a consistency, God bless you. There's a consistency going on with mathematics. A deeper level and a manipulative level. On the manipulative level, yes, you get 40 radical 3. Yes, you get 10 radical 2. But on a deeper level, there's a consistency here, which I think is very important. 2 times 2x is 4x. That is a mechanical level. It's just being able to duplicate or regurgitate the steps. But if we look at it a little bit deeper, this is 2 times anything. And if I double 2 times anything, or if I multiply 2 times 2 times anything, I get 4 times that same anything. Well, in this case, if it's 10 times 4 times a radical 3, that has to be 40 radical 3, because my anything is not changing. Here the x did not change. The x stayed the same. Here the radical 3 stays the same. 5 times 2 times that anything, which is 10 radical 2. So I think it's important to see the consistency of that, okay? That logical consistency, to me, I find comforting. Now, one thing that you will not need to know how to do, it's funny, if you look at this sheet, it says sequences 27A. And I think, Anthony, were you the one who came up to me and said, why does it say 27A?
Yes.
Yeah. The reason it says 27A, I made these sheets the very first year that we taught this course. The very first year we taught this course, I had to teach both integrated algebra, and I also had to teach Common Core Algebra 1. And there were actually 2 Regents exams that year. There was one in early June for Common Core, and then there was one in late June for integrated algebra. This topic of adding and subtracting radicals was on the integrated algebra content or curriculum, but it was not part of Common Core curriculum. So I made up this sheet. I had this big lesson. I called it sheet 27. And then the next year we no longer had to teach integrated algebra. There was only one Regents exam. So I said, okay, let me look through my notes and let me see what didn't work, what did work, what can I change. And I said, oh, okay, we're not going to call it 27 anymore. I'm going to call it 27A. I'm gonna modify it, which I did. So I changed the lesson, and I forgot to change a couple of homework questions. But these are homework questions that should have been changed from 26. And if you see anything like this tonight on your homework sheet, I think there are a couple of questions where they ask you to add and subtract radicals. Disregard them. Don't need to do it. Okay, next, piece of paper. Here's an example of where you can go. Find the area of the piece of paper. It's 93.5, 8.5 times 11. Next up, what would it be if you folded it in half? Divide by 2, 46.75. Now, write a general formula. We talked about this yesterday. If I look at what I have going on here, my first area is 93.5. My second is half of that, which is 46.75. My next is half of that, and so on. If I want to write a formula for this, it's in the form y equals a times b to the n minus 1. A is always the first term. Well, let's call it, in fact, a sub 0. Remember we talked about that yesterday? So the first term is 93.5. This is the common ratio. The common ratio is a half, because you're constantly taking everything and halving it. And it's always the n minus 1 power, because I don't do the 1/2 to the first term. I only do the 1/2 after the first term, so I have to minus the 1. And as far as part D goes, it's 1 and 43/64. There's a decimal equivalent to that. Usually they would ask you to round it to a particular place and you would have it, okay? Any questions? All right. And lastly, geometric arithmetic sequences. Geometric arithmetic sequences. Any questions about those? All right. All right, I think that this is the sheet I want. Nope. I think this is the sheet I want. Yep. Okay. So, let's get to today's lesson. Oh, we didn't do the do it yet. Here's the do it. Is the following sequence arithmetic or geometric? It is arithmetic. And I took that sequence and I put it into the table. Yes?
The reason why they're arithmetic is because the f sides are all going up by 3.
God bless you. Yes, that's perfect explanation. They're going up by a constant amount. An arithmetic sequence has a common difference. That's the amount you're going up by. Geometric doesn't have a common difference. It has a common what? What did you say? A common, never mind? A common ratio. Okay. God bless. Bless you. So, the first term is 5, the second term is 8, third term is 11, and so on. So, a sub n, this is just a way of saying, whichever term it is we're talking about, a is the term. First term, a sub 1. Second term, a sub 2. Third term, a sub 3. Sub again means subscript. A sub 4, and so on. So this is the term, the first term, second term, third term, fourth term. And here's the values, 5, 8, 11, 14, 17, directly from the list there. Write a function rule for the table. Now, we talked about yesterday types of formulas that we call, I didn't even define this term for you yesterday because we didn't need to, but today we do. Explicit formulas. Okay? An explicit formula is really, really good for calculating a specific term. If you remember yesterday, we did something like, let's see, find a sub 50, or find the 100th term, or find the 35th term. Explicit formulas are great for that. That's what they excel at, okay? And we learned when we looked at this yesterday, we said, okay, look, if I look at my sequence here, I'm going up by 3 every time, so that is the common difference. And then we said, okay, that means I have to multiply by 3 to go up each term. And then what I'm also going to do is start with the first term. So starting with 5, I add 3 times n minus 1. Because I don't add 3 to get to the 5. I only add the 3 after the 5. So I have to do n minus 1 so that I don't include the 5. And then the way I include the 5, because the 5 could be 7, it could be 23, whatever, is I do 5 plus 3 times the difference. Or in general, the first term plus the common difference times n minus 1. Yes?
Let's say it will be, how do you know if inside the parentheses is minus or plus 1?
It'll be minus.
Always?
Yeah, because think about it. Do I have to add the 3 to get to the 5?
No.
So I'm not going to include that one, I'm going to exclude it. What operations suggest excluding? Subtraction. Okay?
But I've seen before, I don't know if it was during,
Oh, it's coming. In about 3 minutes, we will get to the plus 1.
okay.
All right. Now, you'll see. Next, another way to do it would be to say a sub n equals, or you can reverse the order, right? Commutative property, switching the order here. Or some people will say f of n equals, and you could, if you wanted to, distribute the 3, then negative 3 plus 5 simplifies to positive 2. All 3 of those are fully acceptable ways to write sequence rules for that. This last way of writing it is very reminiscent of y equals mx plus b, where what you do is you go back to the 0th term, if you will, not the first term, but the preceding term, and that pairs up with 2, so that means that 2 is the y-intercept, b. I put plus 2 over here, and the rate of change is 3, so y equals 3n plus 2, or f of n is 3n plus 2. Any questions? All right. So that's an arithmetic sequence. We went through it on our homework. There was a little bit more geometric than arithmetic. We've taken our time to review that. We've worked it. Now we cover our last piece of sequences. And again, I want to remind you, this is not on the test, but it will be on future tests. Okay. What I'm about to say to you is going to be a little bit confusing in the beginning. But don't let it bug you. Okay? It's really not that complicated, and we'll go through it step by step. Now, yesterday we talked about explicit formulas. Today we're talking about recursive formulas. Recursive. Recursive sounds like this very fancy word. In the English language, a recursive sequence is a sequence that chooses any term and then applies the same rule to create the other terms. First off, let's everybody say the word recursive. Say it. Recursive. Turn to your neighbor and say, recursive means, what we're going to write here, recursive means that it's characterized by a recurrence or repetition. Go ahead, turn to your neighbor, look him in the eye, tell him it. This is the Webster definition of the word recursive. It's characterized by recurrence or repetition. It means you do it over and over again. Okay. Now, all that means is this. Ready? Look. All it means is this. A sub 1. What do you think A sub 1 means? First term. Is 8. Now, what do you think this part means? In terms of operations, what do you think you have to do? Just look at it. What do you think you got to do?
Any term is equal to any term minus 1 plus 2.
Stop. Listen carefully. Just not even knowing about recursive, not even having been taught about recursive. When you look at this, what do you think is going on here? Just look at the math of it. Forget about the symbols and everything else. Come on, look. What do you think?
You're adding 3 to the
Adding
term.
3. 11, 14, 17, 20, 23. Now, just a minute ago, I said to you, this is going to appear confusing, but it's not. What was the most important thing to catch out of all of that? Add 3. Very straightforward. Now, let's talk about understanding it. We've talked about logical consistency, and on the homework, how I love the consistency in math. 2 times 2 times anything is that 4 times anything. So something as weird as 2 times 2 radical 5 Well, that's got to be 4 radical 5. So it seems weird, but there's a consistency to it. Now, I want to start with this one. I'll go back to that one. The hardest thing here is understanding what this says. Growing up, I was a kid. Way back when I used to ride my pet dinosaur to school. My dad, I've told you this before, I think. If my dad referred to me as Robert Carl Lindquist Jr., apparently not.
No, you have.
All right. So it's still humorous.
Chloe just.
If my dad said, Robert Carl Lindquist Jr., the beatings were about to begin. There was never a discussion. I was not asked how I felt about these things. I was simply whooped.
Did you ever try to run?
Oh, yes. Oh, yes. If I have time at the end of the lesson, I will tell you about one great occasion.
You guys stuck in the garage?
Yes, that's the one.
Oh yeah, you told us
All right.
that.
So now, what is this really saying? See, when my dad said Robert, Bud, Bobby, Butch, everything was okay. It meant we were buddies. We were pals. When he said Robert Carl Lindquist Jr., it meant wrath. It meant anger. It meant cover your butt. To my dad's credit, he didn't hit you in the head. Well, once he knocked me out, but other than that, on occasion, well, I called him the crappiest father on the face of the earth, so I think I kind of.
What's that lingo?
Yeah, oh, I used a different word.
You didn't say that like language.
Yes, I used a different word than crappy, though. So, I did, so help me God, it was Halloween day, some kid egged me in the eye. He got it, and the egg shell got stuck in my eye.
Oh my god.
So I came home, and my mom cleaned out my eye, and I looked at my dad and I said, give me $1. He said, I'm not giving you $1. He said, you're in for the rest of the day. I said, no, I'm not. The kid was like 4 years older than me. I said, no, I'm not. Give me $1. I'm gonna go kill that kid. I said, I'm buying a dozen eggs. I'm gonna break every one of them in his eyes. He goes, you're done. You're staying in. I said, no, I'm not. I'm going out. I'm gonna kill that kid. And he said, no, you're done. And I said, you know, you're the boop father on the face of the earth. Bam! And the punch didn't knock me out. So help me, I still remember this. It was on Halloween day. Punch didn't knock me out, but I remember my head slamming into the wall behind me. That knocked me out. So, yep, yeah, that was a great moment in the Lincoln's life right there. So, and yes, this is all being recorded for my mother to hear because she watched the whole thing. So, all right. Now, the truth behind what's being said here, the truth, being able to interpret. As we look here, ready? Robert Carl Lindquist Jr. No. As we look here, what I see is this. I see this, and I see this. Now, let me ask you a question. What number comes after the second number? The third. What comes after the third? Fourth. What comes after the fourth? How do you get from 2 to 3, or from 3 to 4, or from 4 to 5? You add 1 every time. So if I have a term, a general term called the nth term, what would the next term be? The n plus 1 term. So look here, look. Hey, look. This is saying the new term, a sub n plus 1, is the previous term. Doesn't the n plus 1 term have to come after the n term? Right? So the new term is the previous term plus 3. And isn't that how you get up the chart?
Yep.
New term is previous term plus 3. New term is previous term, because isn't n minus 1 before n? Right? N minus 1 is before n. So this is, all you have to do when you read this is, the new term is the previous term plus 3. So this is a recursive sequence. So let's do one more here. Ready? Write 2 recursive formulas that can be used for this. A sub 1 is what? 3. How do I go up each time? No, I'm not adding 3.
You multiply by 2.
Multiply by
That's
2.
like 3
So
times
a
3.
sub n plus 1 is 2 times a sub n.
Oh.
Okay? So this means start with a 3 and then double it. 6, double it. 12, double it. 24, double it. 48, what's next? What's next? 96. So a recursive sequence, let's go back to the definition. It used recurrence or repetition, constantly multiplying by 2. And last but not least, try number 22. Actually, you know what? I'm going to go to 14. Try number 14, see what you get. If you begin with 10 and you have a common difference of 4, first term is 10, new term is previous term plus 4. Choice 1. Alright. Hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot. Ciao, adios amigos y amigas. Cheerio, garushus, gadafis. Calculators up, please.
All jazz band students, please report to the band room at this time. All jazz band students report to the band room at this time.
Jack Castillo to room 205, please. Jack Castillo to room 205.